Storing and retrieving hardware. So we are going to take a look at hardware devices that are used on systems to store data and then access again for later use. So they're mainly going to be secondary storage devices, okay? So where they're stored for longer amounts of time, non-volatile memory, all right? That so we can turn the computer off, then turn it back on again, and then access our data and keep working on it. The first category we'll look at are magnetic disks, and the main example of magnetic disks we're going to talk about is hard drives. Okay, traditionally they were in all computing systems, and now we also have external hard drives as well, which we can use for backing up data outside our system. Okay, data is stored within the disk on sectors, okay, which are sections of the disk where we can write data to. And these sectors are located on the tracks of the disk. So think about a bunch of concentric circles within one circular disk. They are the tracks, and then it's divided up kind of like a pie into equal portions, and that helps put in different sectors onto those tracks. The hard disk drive contains a needle which reads data off the tracks, okay, as the disk is rotated. So if I don't know if you've ever seen an old record, most likely not, okay, but the disk rotates within the hard drive's solid case. And then there's a needle that reads the data off that and reading the zeros and ones, which then get comprehended into the data. Each sector of the disk can usually store up to 512 bytes of data. All right, now we did say they were traditionally on more computers, on most computers. These days, they're not really the main storage area on most systems. We are transitioning more to solid state drives, which I'll get to in a second. Okay, but they used to be the standard of storage within a computing system. The next one we'll look at is optical disc. Okay, and these are our our circular discs. Okay, which we use for putting into a computer and accessing data, and then over time we're able to write to these disks as well. So the data on optical disc is stored in small notches on the disk and is read by a laser from an optical drive. And these lasers differ depending on the type of disk you're using. The optical drive translates the notches read by the laser in its digital representation of ones and zeros into usable data. So once again, the binary data is transformed into real data. Just like magnetic disks, the data is contained within tracks, okay, and the sectors of those tracks. Though in the case of optical disks, the sectors of disk can store up to 2048 bytes of data. The examples here are CDs, DVDs, and Blu-rays of optical disc. Okay, the first two CDs and DVDs are read by a red laser, okay, reading the data from the tracks. But the Blu-ray, as the name suggests, uses a blue laser, which is obviously a lot finer because the data is packed onto the same size disc as the other two, except more congested and more tighter together, and that's why it needs the finer disc to read it, but can store up to 50 to 100 gigabytes of data on that Blu-ray disc. So obviously a large amount of storage. The beauty of the CD was we could, yeah, as I said, take it out of the system, put it into the system, and store stuff externally. They used to be read only, but then with writing technology such as CDRW, rewritable, we could burn data onto the disk at much easier. But still, it was quite the process back in the day, and obviously we've moved in slightly different directions for putting data onto external storage now. Third area is network storage, which is a very common practice these days for the storage mediums, such as hard drives to be contained on a network file server, which multiple systems can access. So all our computers are connected to a file server, okay, and that might be wirelessly or with cabling, and then there's a hard drive on that server where files are stored. All the computers that are connected to that server can access those files, provided they have the permissions based on the network operating system. Essentially, the user connects to these files through the private network or the internet, accessing the system's file server, which is the hard drive stored on those servers, and they can view it online. If you are accessing a website, you are accessing a web server where files are stored through the internet. Okay, so it is an extremely common practice, okay, in most organizations that we use network storage so that all the users can access the data stored on the server. If it was just on individuals' machines, other systems wouldn't be able to access that. Okay, so that's why we need these servers and a great advantage of network storage. The next area is flash memory, which contains a chipset that connects directly to the motherboard. Okay, it allows for high speed storage and retrieval of data. Now, this is kind of the direction we're moving with most of our fast paced storage now because flash memory is found in USB storage devices, SD cards, and solid state drives. So, there it is, the solid state drive, which is now kind of taking over as the main storage on computing systems, as well as being in most mobile devices as well because it's a chipset. It's a lot flatter, has no moving parts, a lot easier to put in, but obviously a lot more expensive. Okay, but it is a lot faster than magnetic disk. Okay, and thus why it's becoming more of the standard now for on-system storage. RAM, which is primary storage, and I've got to make that clear because we'll be mainly talking about secondary storage, is flash memory. Okay, so it actually inserts directly into the motherboard and works and needs to work very quickly because obviously it's working with the CPU in the processing of live data. The final one we look at is kind of going obsolete, and that's magnetic tapes. So tape drives read data that is stored on small cartridges. These cartridges contain magnetic tape, which can be both read and recorded to using sequential access. This means the data needs to be stored in order. So you play the tape, and then you start playing the data, and it will record the data in sequence. Then, when you actually access that data, you need to play it or fast forward or rewind it to find your data. I don't know if you've ever used a VHS tape or a cassette tape for a Walkman. Okay, we're now talking decades ago now with that technology. I'm showing my age. But yes, those use sequential access, okay? And it actually had a magnetic strip inside it, which was the tape that you would fast forward and rewind to find the movie or song that you wanted to access in order to view it. So I hope this is giving you understanding of the types of hardware used for storing and retrieving. All right, and essentially they are secondary storage devices, with this exception of RAM, which is primary storage, which helps us store data for later use. Okay, and then when we want to access it again, we have to go to that storage device and a location within that storage device, retrieve that data so we can continue to use or work on that data.